Greetings, class, and welcome to what is week 13 here in CIS 4710. This week we're going to be looking at the attack and defense chapter 12, I believe it is, in your text. Take a look at that real quick. I have some updating to do, which we'll get done here really quickly. So yeah, chapter 12, attack and defense. Side note, homework 8 is due this week. Let's just take a quick look at that assignment while we're getting things together here. So, seems that we're going to be looking at using Metasploit to dump password hashes and conduct a brute force attack. Pretty simple. So you can use Armitage with that and dump the hashes, or you can get the hashes from Metasploitable 2 in another fashion, and you can crack them with a multitude of tools. You might be able to do it through Armitage. You can definitely do it with John the Ripper. And there's some other good tools out there online that you can use to crack those hashes. So I'm looking for the hashes to be dumped and at least an attempt to crack them for the full 20 points. All right, so let's get back to chapter 12. So attack and defense this week, we're going to look at application attacks, how to defend against application attacks, and the concepts of defense in depth and defense in breadth. Elasticity with defense, if you will. And we're going to look at how defensible network architectures are. So it's a pretty short chapter that we go over. It covers key concepts, and we look at how applications are set up in servers, and we pay particular attention to database servers, application servers, and web servers. And application servers is a very, very open-ended, wide-arcing definition. An application server can be pretty much just about anything. And looking at that, there are intermediate elements that we can and we have to examine in order to ensure that those applications are defended properly. Different attacks will target different elements of the architecture. It could be code, it could be cross-site scripting, it could be focused on dumping data, or focused on a backdoor or a vulnerability to initiate code injection and ultimately gain system control. So, web application attacks, such as cross-site scripting, target the user system and the scripting language or the scripting engine to run in the end user's browser. And the ultimate goal is to gain access to that user's system or data. Cross-site request forgery target the user system and takes advantage of programming functions or problems such as macros on the web server while hiding the request on a page not entirely related to the website itself. And then there's XML external entity or injects, which is going to put data towards a system and reference into XML or by XML being sent to the server. And the target is whatever system that the XML is being computed on or parsed on. There's cross-site scripting, which is kind of tried and true. It targets a database in SQL format, and it's going to send information to that SQL database in the form of a request in order for the SQL database to respond in kind and give you something like data. This could come in the form of usernames, passwords, tables, etc. Command injection with SQL or other types of command execution is going to be targeted at the operating system and be sent in the form of a field to be executed on the system itself. So here we have access to some sort of mechanism that has access to the processing power, RAM, etc. of the victim machine to execute a command to eventually give you something like a command shell. So how do we protect these? Web application protections are somewhat straightforward. Web application firewalls, or WAFs, are highly effective and can identify different attack patterns via signature or heuristic means. And they block or at least log the traffic. Web application firewalls can be problematic because you can have them tuned too tightly to where they basically take down your website or your web application. The best protection are always done in software development, so secure coding practices. All software developers should be aware of secure programming practice. All data should be considered untrustworthy, and always validate your input. This is the big one, especially on the OWASP top 10. Always validate the input that you are receiving. Ensure that it is solid and acceptable before you process it or parse it. There have to be clear boundaries in the application defined with preventative and detective controls in place. So preventative controls such as access list, detective controls such as analysis controls, logging controls that we can actually go back and look at what was done. So different types of application attacks, and these can come in a lot of different types, but the ones we're going to look at here are buffer overflows and heap spraying. And they're memory. They are memory based because, remember, SQL is doing some sort of processing. You're accepting data. That data is held in memory, and then if the memory is not configured properly or defined properly in its usage, we can have problems. And that's where a buffer overflow comes in. That's where we send too much data into an application in order to overflow a specific variable. And this is going to allow the perpetrator to control some sort of variable pointer or instructional pointer and allow the attacker to run or execute code inside the application. So an example of this is where we overload the buffer, and then we are allowed to execute code within the application within RAM. And then we just have to tell it, well, what do we want to execute? Typically, we execute something that's already on system, such as opening up a PowerShell window, for example, or a command shell window, for example, or allowing us to do something within the kernel itself. Heap spraying is a similar type of attack to a buffer overflow, where the goal is to run code, but there's a difference is that it happens on the heap instead of the stack, which is dynamically allocated rather than statically allocated like the stack is. And it may be flagged as a no execute, where the heap is going to be dynamic and it's going to be allowed. They're a little bit more trickier to do a heap spraying than it is a traditional buffer overflow. So for your defense in depth, classic network design introduces security such as firewalls, access control lists, some intrusion prevention. Multiple layers is going to make an attacker's predicament or attempts much more difficult. So this is where we have to get past network defenses, and then we have to get past memory defenses and permissions on file systems, things like that. Having anti-malware in place that actively looks for malware and takes it away, or takes that avenue and doesn't allow it to execute, is also a great positive. They give an example where you may have multiple firewalls between the perimeter and the network. Well, that's good. That's good for network defense, but still we need to have things in place for application defense. Defense in breadth recognizes that attacks can't be prevented solely through technical controls. So this is introducing the defense of the human factor. and it introduces processes of checking people. This could be background checks, this could be reference checks, this could be ongoing drug screening. It could be a multitude of things. And we have to keep this in mind, and we have to keep training our individuals who work for us to constantly refresh their memory about good cyber hygiene, good cyber wellness. So, a defensible network architecture is going to examine and recognize that prevention of attacks are not going to be possible. Now, we can parse them down into a manageable fashion, and we can try to prevent the attacks, but the attacks are still going to happen. And adding detection capabilities to identify where attacks are more likely to take place and shift our defenses in that area is what we're seeing today as best practice in the industry. And that is going to ensure that we have the right controls in the right place, hopefully at the right time, to prevent attacks. So, in summary, web application attacks include cross-site scripting, SQL injection, XML, external entity injection, cross-site request forgery, and command injection. Know the definition of all of those types of attacks and know how, at least at a fundamental definition, how they occur by definition. Protecting web applications should always start with secure programming practices. That cannot be emphasized enough. Too often, programming is not taught in a secure methodology. And it has to include validating input that comes into a web application that eventually hits a database. And that buffer overflows and heap spraying are common application attacks used to circumvent based off of those poor programming practices. Defense in depth is a layered model, layered concept where we have multiple controls in place. Defense in breadth ensures that there's a process to look at our people and our human resources and constantly educate them. And defensible network architecture ensures that everything is in place to detect an attack where it can be, where we think it's going to happen, and try to put as many defenses in place as possible. So that's going to conclude chapter chapter 12, week 13 of 4710. And thank you very much for your attention.